Hey guys, well in this video we're going to go over a very easy trigonometric verification identity problem. It's super easy. If you follow these steps, you will be able to solve this question in a chink. It's so easy. It is proof cosine square x minus cosine to the power 4x minus sine x times sine x plus cosine cube x all over cosine square x plus sine x cosine x minus sine square x is equal to negative 1 over cotangent x. So to get this beginning, first thing we're going to do is we're going to multiply this out. Cosine square x minus cosine to the power 4x minus sine square x minus cosine cube x times sine x. That will be all over cosine squared x plus sine x times cosine x minus sine squared x. The next step, we're going to just do a little simplification in the denominator just to make sure we know where we're going. It's pretty easy actually. So we're going to cancel this out and we're going to say that's equal to cosine x times cosine x plus sine x. So in the numerator, we're going to run across cosine x plus sine x 2 times. Okay, we're going to run across this 2 times. So we have to find how to get this portion 2 times inside this numerator. Okay. So let's get that going. We're going to first, if we look carefully, if we have a sine x here, and we have a just cosine 4x here. So we have cosine cube x, cosine 4x, this right here, and this right here. If we take out a cosine cube x from both these equations, it becomes cosine x minus sine x. And if we take a minus sign out of that as well, it becomes cosine x plus sine x. Okay, so let's rearrange the numerator so it's easy to look at. Okay, so we are going to do minus cosine 4 to the power 4x minus cosine cube x times sine x plus, then we're going to move these 2 terms together, so it's going to be cosine squared x minus sine squared x. Okay, and then we're going to divide everything by cosine x times cosine x plus sine x, and we also have the sine x squared on the right side here as well. Next, we're going to actually take the cosine 4 out, and we're also going to put a bracket over here to show you that this is a perfect square. And we're going to use the perfect square definition to expand this further out as well. So we're going to do minus cosine cube x. I'm going to take it out from these 2 numbers or variables. It's going to be cosine x plus sine x, right? So we have cosine cube taken out from here, it becomes cosine x, and cosine cube negative cosine cube taken out from here, it becomes just sine x. And we have that all over cosine x of cosine x plus sine x. And on this side, as we know, we have a perfect difference squared, so we can expand this out. So this becomes a multiplication of cosine x plus sine x multiplied by cosine x minus sine x, and we're going to also minus sine squared x. Okay, so just to expand this division form, so this is separate, that's all one bracket. And then now we can do something interesting. We can actually we have these 2 variables here, and we have this variable here, and we have a common factor of this portion right here, cosine square x plus sine x square x, cosine square x plus sine square x. Okay, so let's simplify this a little further. We are going to take the cosine square x plus sine square x out from the numerator. It's going to be big bracket and then cosine x plus sine x multiplied by, and this becomes just minus cosine cube x, and then we have plus. We get cosine square x taken out, so we have just cosine x minus sine x, and big bracket, and then we have that all over cosine x times cosine x plus sine x, and then on the right side we have minus sine squared x. Next, we're going to cancel the cosine square x out, so now let's rewrite the equation again. This becomes just minus cosine cube x plus cosine x minus sine x over cosine x, and we have minus sine squared x. Now we're going to actually separate this part out with this part out. So we're going to create this fraction into two smaller fractions. This will be minus cosine cube x over cosine x plus, we're going to separate this part out. It's going to be cosine x minus sine x over cosine x minus sine squared x. Then this cancels out and this becomes 2, so it becomes minus cosine squared x plus cosine x minus sine x over cosine x minus sine squared x. And then we can move this side to the right side, and we can combine the cosine, move the cosine square x and the sine square x variables a little bit closer, because we are going to again use the Pythagorean identity and make that equal to 1. So it's going to be cosine x minus sine x over cosine x minus sine squared x minus cosine squared x. Okay, that's that. Then we will separate again this into two separate equations. This will become two separate fractions. This will become cosine x over cosine x minus sine x over cosine x. Then following that, on the right hand side, we will have minus, we're going to take a minus sign out, and it'll be sine squared x plus cosine squared x. As we know, we have a Pythagorean identity here where sine x squared plus cosine squared x is equal to 1. That's the Pythagorean unicircle identity. And then we have also here, we have cosine x over cosine x, which is 1. So we have 1 minus sine x over cosine x minus 1. Now let's move the like terms together. We have 1 minus sine x over cosine x. And this becomes, let's cancel out, this becomes negative sine x over cosine x. And this becomes negative tan x. And the reciprocal of negative tan x is negative 1 over cotangent x. And we have our answer.